Hello everybody, I am Krishna Rao Patro. Today I will discuss about the two-dimensional array and the matrix operations in Java. How you can perform the matrix operation with the help of two-dimensional array. First we'll see how the two-dimensional array will be look like. Generally when I say two-dimensional array, it is nothing but set of rows and columns. So it is a simple example of a two-dimensional array. There are 3 rows and 3 columns. So it is nothing but a 3 by 3 two-dimensional array. Every two-dimensional array will maintain 2 index. One index per row, another index per column. So by knowing row index and column index, you can identify a particular element. If you want to refer the first element, that will be referred by 0, 0. Similarly, if you refer the next element 0, 1, that means 0th row, first element. If you refer the second element, 0th row, second element. Like this, you can refer a particular element from a two-dimensional array. Similarly, when you come to first row, 0th element, 1, 0. That means this is the 1th row, 0th element of the matrix or the two-dimensional array. Remember, when I say matrix, it is always a two-dimensional array only. Similarly, this is 1 of 1, 1th row, 1th column. This is 1th row, 2nd column. This is 2nd row, 0th column. So here the 2 is row index. This 0 is column index. Similarly, when you come to this place, this is 2nd row, 1st column. That means 2 is the row index, 1 is the column index. Similarly, the last one, 2nd row, 2nd element. Means I require always 2 index. Once you know the 2 index, then you can fetch the element. So this is a simple representation of a two-dimensional array. And remember, always the index start from 0. The column index start from 0. The row index also start from 0. So it is a 3 by 3 matrix. Now, how to declare a two-dimensional array in Java and how to assign the value to the particular place of an array. Let us see the syntax. Two-dimensional array, the simplest form of multi-dimensional array. It is also one type of multi-dimensional array. A two-dimensional array can be seen as array of one-dimensional array. So you can say collection of one dimension is 2 dimension. Collection of one dimension is 2 dimension. First row, second row, every row is a 1 dimension. Here first column, second column. So it is a 3 by 3 two-dimensional array, or it is a 3 by 3 matrix. The syntax for the two-dimensional array. First you have to mention the data type, what kind of data you want to store in the two-dimensional array. Then the symbol, the square bracket symbol, that is the array symbol. If it is a two-dimensional array, you write 2 square bracket. Similarly, the name of the array or name of the matrix. Then this is the way of declaring the name, but you have to initialize, you have to instantiate. For that, you have to allocate memory. So you have to use a special operator called new operator. This is the operator which allows you to allocate memory. Then what type of data, whether integer or character or float or double. So you have to mention the data type. Then you have to mention the row size, how many rows you need for the two-dimensional array. Then you have to mention the number of columns for the matrix or for the two-dimensional array. Now for example, if you observe this syntax, int 2 square bracket ARR. ARR is what? ARR is the name of the array or name of the matrix. The 2 square bracket indicates it is a two-dimensional array, and simply declaring is not enough. You have to instantiate. That means you have to allocate memory. So for allocating memory, you have to use new operator followed by which kind of data. Then write, because I want to store integer data, write int 10 of 20. That means what? There are 10 rows, 20 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 rows, 20 columns. 1, 2, 3, 4, like this up to 20 columns. So this is 10 by 20 two-dimensional array. So once you write this statement, automatically 20 into 10, 200 integers you can store in the array. Okay. So the initialization syntax is this. You can initialize a particular value at a particular place. Example, a of 0 equal 1. That means 0th row, 0th column. Here This is the 0th row and this is the 0th column. Here you can store 1. So you can mention the row index and column index to store the data. So a particular value you can assign in a particular place by specifying the two index. So this is the way you can deal with two-dimensional array. This is the try to know the array syntax and how to instantiate. Then we will see a small program how you can store the data and how you can print the data. Assume I want to have a 4x4 array. 4x4 array. That means what? 4 rows, 4 columns. Public class two-dimensional array. 2D array means two-dimensional array. Then here I wrote the main method. Public static void main. Row is equal to 4, columns is 4. That means what? I want to have 4 rows and 4 columns. For that, I wrote a syntax. Int 2 square bracket, then array, new int rows comma columns. So that means you are allocating memory for 4 rows and 4 columns. So automatically the 4 rows 1, 2, 3, 4. 4 columns, first column, second column, third column, fourth column. So this much memory will be allocated once you write this statement. In that place, this is first row, second row, third row, fourth row. First column, second column, third column, fourth column. 0, 1, 2, 3. 0, 1, 2, 3. Now, this loop is repeating. How many times is repeating? I equal 0, I less than rows. That means rows time. That means outer loop repeats. Row means 4. 4 times repeats. For each row, how many columns are there? 4 columns. So, this inner loop repeats 4 times again. Under each position of the or under each location of the two-dimensional array, you have to store a value. Initially, the value is 1. Initially, I is 0, 0, j also 0. So, I stand for row index, j stand for column index. 0th row, 0th column. So, this loop repeats for entire row. Initially, I is 0. This is 0th row. 0th row. This 0th row is assigned with some value. 0th row, 0th column. Value is 1. After storing 1, value is incremented to 2. So, this loop repeats again. J plus plus. 0th row, 1th column. Because j is incrementing. For every I, this loop repeats 4 times. 0th row, 0th column. Now, 0th row, second column. Because already value is incremented, so 2 will be stored. Again, j plus plus. 0th row, second column. Here 3 will be stored. Because every time value is updating. Means after storing, it is incrementing. Then 4. After repeating 4 times, this internal loop will break. Then it goes to outer loop. This outer loop, what is doing? Row index is changing. Because I stands for row index, j stands for column index. Then it comes to the second row. In second row, what is storing? 1th row, because again j stands for 0. Row is 1, column is 0, so it comes here. Here, which value will be stored? Because after repeating 4 times, the value 4 is stored. After storing, value is incremented. So 5 will be printed. Then repeats 6, 7, 8. After repeating 4 times, again the control goes to outer loop. Again I plus plus. I comes to this row, second row. Second row, 0th column. Now again j starts from 0. Second row, 0th column. So next element 9, 10, 11, 12. After storing 4 elements, again this internal loop will over. Again goes to outer loop. Because it is a loop within a loop. So this is your which loop? This is your nested loop. Okay. After storing 12, it comes to the last row. Then 13, 14, 15, 16. After storing 16, j plus plus again goes to outer loop. This outer loop now how much? This become 4. So, but already rows is 4. 4 is less than 4. No. So, condition fail. When the condition fail, this loop over comes out of the loop. So, is there that storing element is over. Now, it will print two-dimensional array is 2D array. is, it will come, and this loop, what is doing? It is trying to print every element, whatever the value you have stored in the array, that will be printing. I equal 0, I less than rows, I plus plus. That means this outer loop repeats 4 times because there are 4 rows. For each row, again the inner loop repeats how many times? Columns time. For every row, it repeats columns time. Columns means how much? 4. 4 times. So it will print what? Whatever the data is available in the array. What is the name of the array? ARR. Sorry, array. This array value is printed. 0th row, 0th column. That is 1. Then 1, 2, 3, 4. After printing first row, then there is a statement called println. Then the cursor will come to next line. Again I plus plus. Now it goes to initially 0th row over. Now 1th row. 1th row, 0th column. 1th row, 0th column 5. So 5, 6, 7, 8. After repeating 4 times, again go to next. 9, 10, 11, 12. After printing 12, again go to next row. Because it has to repeat how many times? 4 times. Then 13, 14, 15, 16. So it repeats 4 times. After repeating 4 times, this loop will over. That means entire the 2-dimensional array is printed. So your goal is what? Store value and print value. Store the value in the 2-dimensional array and print the value from the 2-dimensional array. So in this way, you can write this program. So whenever the matrix program comes, you have to use this type of program. So remember, for matrix, always you have to use nested loop. Loop within a loop. Now we'll see how to initialize the value. In the previous program, if you observe, I have assigned 1 by 1. I have assigned 1 by 1. Here, it was assigning. This is assigning. Now, instead of assigning, I will initialize. Initialize means I will be keeping the data at the beginning itself. I will not assign 1 by 1. So, this is an example of initialization. That means what? Int 2 square bracket ARR. So, it means it is a 2-dimensional array. This first 2 curly brace, that is 1 row. Second curly brace, that is second row. That means there are 2 rows. There are 2 rows. Under each row, how many columns are there? 1, 2. That means the first row will have 1 and 2. 3, 4, that go to second row. 3, 4. So, this is 0th row, this is 1th row. This is 0th column, this is first column. So, in this format, the data is stored. So, 1, 2 stored in the 0th row, 3, 4 stored in the second row. Second row. Now, once the data is stored, now I want to display on the screen. So, remember when you write this statement, automatically value will be stored in a row by row format. This represents first row, but 0th row. This represents first row. And 1 and 2 comes under the first row. 3 and 4 comes under the second row in a sequential order. In a sequential order. Now, if you observe this program, for int I equal 0, I less than 2, I plus plus. That means this loop repeats 2 times because there are 2 rows. If there are 3 rows, then you should write 3. If there are 4 rows, you should write 4. So, outer loop controls number of rows. Outer loop controls number of rows. Okay. So, 2 times. Then for each row, this loop repeats how many times? 2 times because there are 2 columns. Now, it is printing ARR of I value. What is the value of I? I value is initially 0. Again square bracket, J value, that is also 0. So 0th row, 0th column. That means it is going to print the name of the array. So ARR of 0, because I value 0, then square bracket, again square bracket begins. J value, what is the J value? J value also 0, then square bracket, then equal to symbol, equal to ARR of I comma J. That means 0th row, 0th column, how much? 1. So 1 will be printed. After printing this, because this is a println statement, automatically the cursor comes to next line. ARR of, because I is 0 only, 0th row, but J is incrementing, 1th column equal to 0th row 1th column. 0th row 1th column. That means 2. So 2 will be printed. So like this, it go to the second row. ARR of, because after finishing the first row, again go second row. So 1th row. 1 of, again J value start from 0. 0th column equal to 1th row, 0th column equal to 3. So 3 will be printed. 3 will be printed. Now again ARR of 1th row, again 1th column equal to how much? 4. So this is the your required output. Once you execute this program, you will get this output. So by specifying a particular index, you can go there and fetch the data. So this is the way array is initialized as well as array is printed on the screen. So most of the time, whenever we are using the matrix programs or whenever you are writing matrix program, that time you use a 2-dimensional array. Now let us do the matrix addition using Java. So when I say matrix addition, so how many array you need? When I say matrix addition, A is one matrix, B is another matrix, then you will get one matrix C. So that means you need a 2-dimensional array, as well as you need one more 2-dimensional array, as well as you need one more 2-dimensional array. That means this is the first matrix, this is the second matrix, this is the third matrix. That means you need 3 2-dimensional array. 3 2-dimensional array. And every matrix will have a same dimension, equal dimension. If it is a 2x2 matrix, this should be also 2x2 matrix. This should be also 2x2 matrix. That means you have to declare 3 2-dimensional array. If it is a 3x3, this should be also 3x3. This should be also 3x3. Because for matrix operation, both the matrix must have same dimension. Same dimension. Dimension means what? Number of rows and number of columns. That is called dimension. Now, matrix 1 is given 1, 3, 4, 2, 4, 3, 3, 4, 5. This is whatever matrix. This is a 3x3 matrix. That means it is a 2-dimensional array. With row size 3, column size also 3. Similarly, matrix 2. This is also a 2-dimensional array. 1, 3, 4, 2, 4, 3, 1, 2, 4. This is also a 3x3 matrix. 3x3 matrix. Now, if you want to add 2 matrix, how will you add? This value is added with this value. So 1 plus 1. This is the final matrix. My resultant matrix. Then this is 3. This is 3. So 3 plus 3. And this is 4, 4. That means 4 plus 4. 4 plus 4. Now come to this. This is second. This is second. That means because you have to add the corresponding index. So 2 plus 2. This is 4. This is 4. 4 plus 4. This is 3. This is also 3. So 3 plus 3. This is 3. This is 1. So 3 plus 1. This is 4. This is 2. So 4 plus 2. This is 5. This is 4. 5 plus 4. So you are able to add the corresponding elements of both the matrix. And finally you got the resultant matrix. So 1 plus 1 is 2. 3 plus 3 is 6. 4 plus 4 is 8. 2 plus 2 is 4. 4 plus 4, 8. 3 plus 3, 6. 3 plus 1, 4. And 4 plus 2, 6. 5 plus 4, 9. So this is my resultant matrix. This should be also 3x3 matrix. 3x3 matrix. Now, most of the time in exam, they may ask, write a program to add 2 matrix. Then you have to declare 3 2-dimensional array. Then do the addition. What you have to do? You have to add the corresponding element. This is 0, 0 of the first matrix A. This is 0, 0 of second matrix B. That has to be stored in the resultant matrix C. So that means A of ith row, jth column is added with B of ith row, jth column. If you take the corresponding element, then you can store in C. C of ith row, jth column. So this I and J will be changing. I refers my row index, J refers my column index. It has to repeat in a nested loop so that corresponding element will be added. Similarly, subtraction also you can do. Just like addition, you can do subtraction also. Instead of plus, if you put minus, that become matrix subtraction. Now we'll see how to write a program for this. See, I'm having a matrix A. See, when you write like this, A within, when there are two square brackets, that means it is a two-dimensional array. There are three curly brackets. First curly bracket here, second curly bracket here, third curly bracket here. That means there are three rows. That indicates what? Three rows. Under each curly bracket, 1, 2, 3, three columns. 1, 2, 3, three columns. 1, 2, 3, three columns. That means what? It is a matrix with 3 rows and 3 columns. 3 rows and 3 columns. First row having 1, 3, 4. 1, 3, 4. Second row 2, 4, 3. Third row 3, 4, 5. This is called what? Matrix initialization or a two-dimensional array initialization. You have initialized the array with the value. So this is the way. Similarly, B is another matrix. B is another matrix. How many rows? First row, second row, third row. So please remember, the curly bracket indicates one row. So that means this is nested curly brackets. Curly bracket within a curly bracket. This main one is the main matrix. Then each one is one row. Here also 1, 3, 4. 1, 3, 4. Second row 2, 4, 3. Third row 1, 2, 4. So my two matrices are initialized. Then the resultant matrix is C. Resultant matrix is C. So this two you have to put in C. Now create another matrix to store the sum of two matrices and adding and two matrices. So now my first matrix having how many rows? 3 rows, 3 columns. Second matrix 3 rows, 3. So my resultant matrix should be also 3 by 3. That's why I wrote 3 by 3. 3 by 3. If the dimension changes, then you cannot do addition. So resultant matrix dimension should be same as A and B. Now when you want to add two matrix, what you have to do? First put a outer loop. This loop starts from 0 until less than 3 and I print. That means there are 3 rows. I equal 0, I less than 3, I print. Because I have to add row by row. For every row, how many columns are there? Again, 3 columns. So this will repeat 3 times. So that means I am adding first row, then adding second row, then adding third row. So what is the logic? C of ij equal to A of ij plus B of ij. So when you write this statement, automatically ith row and ith column of first matrix, this means 1, and ith row, jth column of second matrix is added and stored in C. So that means 1 plus 1, 2 will be stored here automatically. Because this is 0th row, jth column. Next, after that, it prints the value. What is there? Print is there. So that means 2 is printed on the screen. First it will store and then print. After that, again go to the next element. Which element? Next column. 0th row only. So here 3, here 3. So 3 plus 3, how much? 6. 6 is stored here and then printed on the screen. So 2, 6. After that, again j plus plus. Now j become 2. So 0th row, second element. 0th row, second element. 0th row, second element. 1, 2. 0, 1, 2. Yeah. So here 4, here also 4. 4 plus 4, 8. Then the 8 is printed. After printing 8, then j plus plus. J becomes 3. 3 is less than 3? No. So that means after printing the complete row, this loop will terminate. After that, there is a new line. Then the cursor will come to next line. Because after printing first row, then the cursor comes to next row. Then control goes to outer row. Here. When you come to next row, here 2, here 2. 2 plus 2, 4. 4 is stored here. After storing 4, print on the screen. 4 is printed. Then j plus plus. Here 4, here also 4. 4, 4, 4, 8. then print, then A++. Here 3, here also 3. 3 plus 3, 6. So 6 is printed. 6 is printed. After that, the cursor come to next. Again I++, that goes to next row. In next row 3 is there, here 1 is there. 3 plus 1, 4. So 4 is printed. Then next 4 is there, here 2 is there. 4 plus 2, 6. So 6 is printed. Then next 5, 4. 5 plus 4, 9. Then 9 is printed. After printing this comes out of the loop. Then goes to outer loop. When you go to outer loop, the row become 3. 3 is less than 3. No. Because 0, 1, 2. 3 rows over. Whenever I become 3, the condition fail, then the loop will stop. That says my addition operation is over and printing also over. So this is a simple program to add two matrices. So you may get this question in the examination also, as well as in a future placement drive also. So try to go through this program. Then, of course, for subtraction, what do you do? Because subtraction means A of ij minus B of ij. So instead of plus operation, here if you put minus, that become matrix subtraction. Because you have to subtract A of ij minus B of ij, store in C of ij. If you write this logic, then this program meant for matrix subtraction. So I hope you can do the matrix subtraction program by simply changing plus with minus. So this you can do. So now we'll go for next program, that is matrix multiplication. For matrix multiplication, there are some constraints. You must know that one also. Assume this is m rows, n columns. There is a matrix A with m rows, n columns. Here there is another matrix. Assume n rows are columns. N rows are columns. For matrix multiplication, there is a condition. What is the condition? The number of columns of first matrix must be equal to number of columns of second matrix. Number of columns of first matrix equal to number of rows of second matrix. If both are equal, then matrix multiplication is possible. That means if it is 2 by 3 and if it is 3 by 2, then it is possible because 3 columns, here 3 rows. Finally, the resultant matrix is 2 by 2. Similarly, here also, m into n, here n into r. If you multiply these two, my resultant matrix will be m into r. Similarly, here also, it is a 3 by 3 matrix. Here also 3 by 3 matrix. So 3, 3 cancel. So 3 by 3. So it is a 3 by 3 matrix. So the resultant matrix is 3 by 3. For that, how to calculate the value? It is a 3 by 3 matrix. For matrix multiplication, there is a formula. To find the value for 0, 0, 0, 0th row, 0th column, how to multiply? 0th row, you have to multiply with 0th column with corresponding element. A multiply with R, then B multiply with U, then C multiply with X. You multiply each element, add it. If you add everything, then you will get a final value. That is the value to be stored at 0, 0. Similarly, 0th row, 1th column. 0th row, 1th column. So 0th row of the first matrix multiply with the first column. This is the first column. A multiply with S, AS. B multiply with V, VV. C multiply with Y, so CY. Add everything, then you will get 0, 1. So multiply and add, then you will get a final value. That value you have to store in the 0th row, 1th column of the resultant matrix. This is the C. Now 0th row, 2nd column. 0th row, 2nd column. Multiply 0th row with first, 2nd column. This is 0th column, 1st column, 2nd column. A with T, AT. B with W, BW. C with Z, CZ. Add everything, then you will get one value. that is stored at 0, 2. 0, 2. Now come to this 1th row, 0th column. 1th row, 0th column. 1th row of the first matrix, 0th column of second matrix. D with R, DR. E with U, EU. F with X, FX. If you add everything, then you will get one value. That value you have to store at 1, 0. Similarly, this is 1th row, 1th column. This row, 1th row and 1th column. So, from one matrix row, another matrix column. The corresponding positional value you have to multiply and add it. So, in this way, you will continue for all the elements. Okay? I will explain the second 2 by 2. That means second row, second column. Second row of the first matrix, second column of second matrix. G with T, GT. H with W, HW. I with Z, IZ. Multiply and add. Then you will get a value. That value you have to store at 2, 2. So, this is generally the matrix multiplication process. So, now this process you have to implement through Java. So, to solve this problem, how many two-dimensional array I need? I need one matrix for A, one matrix for B, and one matrix for C. That means I need a 3 two-dimensional array. As well as to store the data, then I need a nested loop. Here also nested loop. Here also a nested loop within a nested loop. Because here, if you observe, every element you have to multiply and add. Every element you have to multiply and add. How many times you have to multiply? Because that many rows, that many columns with that many rows. So internally, my n time I should multiply to add. So that I will get a corresponding. Let us see how to write a Java program for multiplying two matrices. Now, I told you to solve this program, you need how many matrix? 3 matrix. The first matrix is given here. This is 3 rows because see, if you observe, there are 3 curly braces internally. Nested curly braces. That means there are 3 rows. And how many columns? 1, 2, 3. 3. So 3 by 3. This is the first matrix. 1, 1, 1, first row. 2, 2, 2, second row. 3, 3, 3. This is 3 by 3 matrix. Next, B matrix. This is A. Similarly, B matrix. B is how much? This is also 3 by 3. Here also 1, 1, 1. 1, 1, 1. Then 2, 2, 2, 2, 2, 2. Then 3, 3, 3. 3, 3, 3. 3, 3, 3. That means what? I am having 2 3 by 3 matrix. So what should be the resultant matrix? Because for the resultant matrix, the dimension should be, these two should be same. So 3 by 3. This is the resultant matrix. 3 by 3. This is the row size of the first matrix. This is the column size of second matrix. So my resultant matrix should be 3 by 3. So that's why 3 by 3. 3 by 3. Now, you have to fetch the data of each element of the first row with first column. So now, my resultant matrix, this is 3 by 3. This is 0, 0. 0th row, 0th column. So, how to fetch the value for the 0th row, 0th column? For 0th row, 0th column, I have to multiply the first row, the 0th row of the first matrix and 0th column of the second matrix. I have to multiply and add. So, how to multiply? How many times I have to multiply? That is nothing but number of columns of first matrix or nothing but number of rows of second matrix. So, that is why my resultant matrix C, initially 0 is there. Nothing is there. All the elements are filled with 0 initially. Because when you are initializing, initially 0 is there. Now, you have to multiply 1 with 1, then 1 with 2, then 1 with 3. First row with first column. Multiply and add. So, how many times I have to multiply? 0, 1, 2. Here also 0, 1, 2. That means my loop repeats 3 times. This is nothing but number of columns of first matrix. This is nothing but number of rows of second matrix. That is also 3. So my innermost loop, which will repeat again 3 times. So here you require 3 index I, J, K. This I stands for my row index and J stands for my column index. Okay. At 0th row, 0th column, I have to store some value. Which value I have to store? I have to go through the complete set of elements with complete columns of the second matrix. So now, as it takes to repeat 3 times, my loop repeats k equal 0, k less than 3, k plus plus, a of ik into b of kj. That means this k goes column wise. Here this k goes row wise. That means a goes in this order and for b the k goes in this order because you have to multiply the corresponding element. So 0th row, 0th column multiplied with 0th row, 0th column, multiply and add. Then next 0th row, 1th column, 0th row, 1th column, multiply with 1th row, 0th column, 1th row, 0th column, add it. So every time you have to go in a opposite direction. This goes horizontal, that goes vertical. So corresponding value, which is changing, the k value changing. For first matrix, the k acts like a column. For second matrix, k acts like a row. So that's why this k value you have to write in a proper place. Multiply and add. Multiply and add. How many times it will add? 3 times. Because there are 3 elements. Once this loop is over, the complete calculation is over here. Again go to the second. Whatever the value comes, print it. Then go to the next. Then you have to compute these 3. How many times? 1, 2, 3 times. Compute and add. After that, come to this. Here also it has to repeat how many times? 3 times. After repeating 3 times, that means one row is over. This row is over. Then come to next line. Then go to next line. Here, after that, again start. This is 1th row, 0th column. 1th row, 1th column. 1th row, 2nd column. So, this process is continuing for same way. And this is 2nd row, 1th, 0th. 2nd row, 0th column. 2nd row, 1th column. 2nd row, 2nd column. So, this process will continue till end. At the end of the loop, my complete matrix multiplication will be over as well as displaying will be also over because it is calculating and displaying. So this is the way the matrix multiplication works. Now, if possible, I will write in a generalized way. This is static way. This is static way. Then we'll go for generalized way. How we can do in a generalized form. I'll open my notepad. I'll show you how you can do matrix multiplication generalized way. Matrix multiplication in generalized format. Generalized format. That means what? Number of rows and number of columns I should ask the user. It is not static. I want to make it dynamic. So, first we will go for program called class matrix multiply. Matmul. This is a name. And I said it should be generalized. That means I should ask the user how many rows and how many columns. Public static void main string arguments array. Okay. As I said, it is a matrix multiplication. So I need 3 two-dimensional array. So I'll write int a of 2 square bracket. This is the first matrix, comma b of 2 square bracket. It is the second 2 dimension, and c of 2. That means the declaration of the 3 matrix over. But what is the size? What is the dimension? So here I will declare int R1, C1. R1 is the number of rows, C1 is the number of columns of the first matrix, comma R2, comma C2. R2 is what? Number of rows of second matrix. C2 is the number of columns of second matrix. So, based upon the R1, C1 and R2, C2, then my matrix multiplication possible. So, for matrix multiplication, I told you one condition. What is the condition? The condition is number of columns of first matrix must be equal to number of rows of second matrix. Number of columns of first matrix must be same as number of columns of second matrix. Must be same as number of rows of second matrix. This is the condition you should know whenever you want to multiply two matrices. If both are not matching, then immediately you can say it is not possible. So, okay. So, in this example, the number of column of first matrix, which is the number of columns, that is C1. And number of rows of second matrix, that is R2. So, that means these two values must be equal. If these two values are not equal, then immediately I will say matrix multiplication not possible. So, you can reject. So, now let us read the value for R1, C1 and R2, C2. So, how to read? Let me use the util package scanner class. So, let me declare one scanner class. Scanner SC equal to new scanner within bracket system.in. So, my scanner object is ready to read the data. But scanner class belongs to which package? This belongs to util package. So, I have to import java.util.star. So, I am importing the scanner class from the util package. Now, here I will ask the user enter the number of rows, number of columns of first matrix and number of rows and number of columns of second matrix. That value I should read. Tell me how to read. I will ask the user system.out.println enter number of rows, enter number of rows and number of columns of first matrix, matrix A. Now you have to read it. My R1 is what? Rows of first matrix. C1 is number of columns of first matrix. So I will read this value. R1 equal to SC dot next int. I am reading the first matrix. Then C1 equal to SC dot next int. Reading the number of rows and number of columns of first matrix over. Similarly, I will read what? Number of columns and number of columns of second matrix. Now, I will print a message. Enter the number of rows and columns of matrix B. Matrix B. Because I am having the matrix A and matrix B. For matrix C, I will not read. Because matrix C size depends upon the dimension of first matrix and second matrix. So that's why I am not reading the dimension of C. C is my resultant matrix. Okay. Now, this is what? R2. This is C2. Now, I have to check whether these dimensions are eligible or not for multiplication. What condition I have to check? Number of columns of first matrix equal to number of rows of second matrix. If both are equal, multiplication possible. Else, not possible. So, I will put a condition. If number of columns of first matrix, if it is not equal to number of rows of second matrix, then immediately I will reject. Matrix multiplication not possible. I'll print a message system dot out dot println matrix multiplication not possible. This message I'll display reject and go. The control should go away. I will not allow to go further. I will stop there itself because dimensions are not matching. If dimensions are not matching, you cannot do multiplication. If it is equal, then come to else part. Here, else, I will come here. Else, here I will do my process. What is the process? I will repeat from 0th row to till last row of the first matrix for int I equal to 0 until I less than the number of rows of first matrix, that means R1, I plus plus. Okay, this is my outer loop. This loop repeats 7 times until all rows are over. Until all rows are over. Again, for every row, I have to multiply every column of the second matrix. So for int j equal to 0 until j less than how many, because I have to store the data in the resultant matrix. So what is the dimension of resultant matrix? The dimension of the resultant matrix is, if you observe here, as I'll put comment, R1 into C1 is the dimension of first matrix. R1 into C1 must be, you are multiplying with R2 into C2. So once you multiply, what is the resultant matrix? Because these two will be cancelling each other. These two will be cancelling each other. Because this C1 is equal to R2. So the resultant matrix will be R1 into C2. So the dimension of resultant matrix is R1 rows, C2 columns. That is why what I will do here, I will write here C2. Because you are storing the data in the resultant matrix. So my loop should repeat until C2 time. This many columns should produce J plus plus. Now this is my number of rows and number of columns of resultant matrix. Fine. But every element of the matrix I have to compute. So how many times I have to compute? Because whatever the columns are there for the first matrix, that many times you have to multiply. Or whatever the rows of the second matrix is there, that many times you have to multiply. So internally, my resultant matrix C of ith row jth column must be initially 0. Okay, initially 0. In that place, I have to store the corresponding multiplication. So for I am making one variable integer k. That k will be controlling how many times I should traverse in the row and how many times I should traverse in the column. So until k less than how many times? Because the k is completely controlled by either C1 or R2. That many times I have to multiply so that I can compute the element of resultant matrix. So k less than, either I can write C1 or I can write R2. Both are same because both are equal. And k plus plus. K plus plus. Now that value where I have to store? In the resultant matrix C of ij. C of ith row jth column is added with C of A of ith row, and I should traverse in the k direction of ith row kth element multiplied by B second matrix kth row and jth column. Here for first matrix k goes row wise, for second matrix k goes to column wise. Okay, so multiply these two and add it. Once the complete internal loop is over, this loop is over, one element of the resultant matrix is computed. One element of resultant matrix is computed. After that, you have to print it on the screen. So how to print? System dot out dot println. But I have to print row by row. I should not write println. I should write print because I want to print in a row. Print. What I have to print? Final value. The final value is stored in C of ij. So C of ith row, jth column. After printing each element, I should give a space. So I should give a gap. Yeah. So now this loop repeats how many times? Complete row of the resultant matrix. After printing the complete row, the cursor has come to next line. So how to bring the cursor to next line? To bring the cursor to next line, I should write system dot out dot println one new line. Either you can write or you can write one empty string. Both are correct. So once you write this statement, automatically after printing first row, the cursor will come to next row. Then again repeat 3 times. After printing second row, again the cursor comes to third row. So this statement, last statement, the println statement brings the cursor to next line. So keep on, repeat, and finally the loop is over. But here one thing you should remember. Here what I did, please observe, only matrix means the two-dimensional arrays are declared only, but memory is not allocated. If memory is not allocated, then how will you store the data? That part is missing. So how much memory I have to allocate? That you have to decide based upon R1 and C1. So here what I will do, when the columns and rows are equal, come to else path. Here in the else path, I will allocate memory. I will allocate memory for what? For A, for B, as well as for C also. Because you have to store the data in the resultant matrix. A equal to new, because when you write new, the memory is allocated. What type of data? That is integer data. How many rows? R1 rows. And how many columns? C1 columns. If you write this statement, then the matrix will be getting memory and that will be initialized with initially 0. Then B second matrix. B equal to new int. For second matrix, what is the dimension? R2 rows. R2 rows. And how many columns? C2 columns. So this is the second matrix. First matrix is over, second matrix is over. And then you have to allocate memory for resultant matrix also. So how to allocate memory for resultant matrix? C equal to new. Here you have to decide how many rows and how many columns of the resultant matrix. New, tell me, int, because int is the data type. Here in a square bracket, what I would write? That is the number of rows of resultant matrix. So already I think I have shown you this is the dimension of resultant matrix. R1, C2. So that means here I can write R1, that many rows, and how many columns? C2 columns. Yeah. If you write these 3 statements, then the memory will be allocated for the 3 two-dimensional array or 3 matrix. Once memory is allocated, then you can do processing. Without allocation of memory, you cannot do. Then you will get a special error, array index out of bounds exception. Control C. So let me store the data. What is the name of the array? matmul. Control S. matmul. Control V. Java. Source file. Okay. matmul is over. Then go to the command prompt. Yes. Now Java C. matmul. Java. Now still there is a small error. New scanner. System.in. In system.in, system S should be uppercase. So because the built-in class, S must be uppercase. Fine. And here int k I have written, but I have not initialized. What is the value of k? K is not initialized. So in the inner loop, k is not initialized. Here you should write k equal to because you have to start from 0th place, A equals 0. Fine. Again, compile. Yeah, now no error. Successfully compiled. Once it's compiled, then you will run Java. Followed by matmul. How many rows? Assume 2 rows, 3 columns. This is 3 rows, 2 columns. That means this is 2 by 3, that is 3 by 2. So the resultant is 2 by 2. And finally my answer is 0, 0. Because I did not read the data for the both the matrix. So if data is not there, then it will take the 0. The default value of the matrix is 0, 0. So that's the answer is 0, 0. So now I want to read my own value. So after allocating memory is allocated. But in that matrix, what data is there? You have not mentioned. So I have to read the data. So how to read the data? So here I should ask, put a loop. Here I'll ask the user system.out.println enter data for matrix A. How much time you have to read? Because there are R1 rows, C1 columns. That many data R1 into C1 times I have to enter the data. So put a loop for int I equal 0, I less than R1 time, that many rows, and I plus plus. For each row, how many columns? Again, C1 columns. Put a loop again for int j equal 0 until j less than C1 times and j plus plus. Fine. Now, inside the loop, because I throw jth column, the data I have to read. Where I have to store? In A is the first matrix, I is the row index, j is the column index, A of I throw jth column must be assigned with a value. That value I have to read from keyboard. How to read from keyboard? There is a object called SC, scanner object. Using scanner object, I can read the integer. So here what I will do? Using scanner object, here I will write SC dot next int. So R1 into C1 times that many data I have to enter for the first matrix. In the similar way, after reading for the first matrix, then I have to enter the data for second matrix. Here, now I will enter the data for matrix B. For matrix B, what I have to do? Same, I equal 0, that means 0th index, until R2 rows. And for every row, how many columns? C2 columns. Then, where I have to store? In the matrix B. So, this loop is reading the data for matrix B. Now, after reading the data for matrix A and B, then it is doing matrix multiplication as well as printing. So, here I will print a message, the resultant matrix. Here, I will print the resultant matrix. Resultant matrix C. Control S. Assume I am entering 2 by 3. If I enter, for example, I will enter 2 by 3 with 3 by 2. 2 by 3 into 2 by 2. So, what is the final matrix? Because 3 by 3 cancel. So, the resultant matrix is 2 rows, 2 columns. That means I will get 4 elements. So, now let me enter 2, 3 and 3, 2. Control S. Compile it. Yes, I have compiled. Matrix multiplication. 2 rows, 3 columns. This is 3 rows, 2 columns. So I got the dimension of first matrix and second matrix. Now I will read the data. Assume 1, 2, 3, 4. Because 2 by 3 means 6 element. 5, 6. This is the first matrix. Then it is asking enter the second matrix. Second matrix how much? Assume there also I will enter. 1, 2, 3, 4, 5, 6. Yeah. Finally, I got my resultant matrix. So all the 6 elements of first matrix and second matrix I have entered, and I got the resultant matrix. So this is the way you can solve this matrix program. Of course, while entering data, you can enter in a sequential way also, or you can enter the data in a matrix form. Now, let us enter the matrix form. 2 rows, 3 columns. 2 rows, 3 columns. 3 rows, 2 columns. First matrix. 2 rows, 3 columns. That means 1, 2, 3. First row. 4, 5, 6. Second row. This way also you can enter. Similarly, 1, 2. First row. 3, 4. Second row. 5, 6. Third row. Yeah, answer is same only. You can enter the data in any form. You can enter everything in a sequence 1, 2, 3, 4, 5, 6 or 1, 2, 3, 4, 5, 6. So, space delimiter plays the major role here to take the data. So, entry doesn't matter. You can enter in a matrix form or you can enter in a sequential form. Finally, the resultant matrix is this. Because if you multiply 1, 2, 3 with 1, 3, 5. Then 1, 2, 3 with 2, 4, 6. If you multiply, then you will get the corresponding values. Multiply and add. So, in this way, you can write your matrix multiplication program. I hope it is clear. So, once again, you can go through this video and you can understand and try to solve yourself. First, go through video and type the program and execute. Whenever there is a mistake, again go through video. Okay? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.